Hi, my name is Brad Cunningham. Today I want to show you a quick walkthrough of a TODO application built on Windows Phone. Now this video is built for the San Diego Tech Immersion group, but it should be useful to anybody watching. What we're going to do is walk through a simple application architecture for this app, and we're building this application in the context of cross-platform mobile development. So we're going to start with Windows Phone as our first platform, and then we're going to port this same application over to Android and iOS by using the Xamarin Tools. Before we get started, I want to show you a walkthrough of the completed application in the context of Windows Phone and show you how all the pieces fit together. So the first thing I'm going to do is open my project here that I have, and we preface this with tig.todo. And for those of you that aren't part of the TIG group and are wondering maybe where you can get this code, we've hosted this on GitHub publicly, so you can feel free to just clone this repository. If you navigate to GitHub and search for TIG dash cross-platform mobile, you should find our repository here. Clone this entire repository down to your desktop, and you should be able to follow along with the same code that we're using. One thing to note, that this application is built and leverages the portable class libraries. That's a function that's not available in the Express version of Visual Studio. So if you followed an earlier video of mine, getting started with Windows Phone development, that video used the Express version. This project will not open correctly in the Express version because of the use of portable class libraries. We'll talk more about the PCL in later videos. If you're in Visual Studio 2013, one nice new feature is the Git tools that are integrated directly into the Team Explorer window. So when you come into Team Explorer from the home screen, you can add a new Git repository, and from there you can clone the TIG repo straight off of GitHub. So you wouldn't even have to navigate to github.com. You could do it all within Visual Studio. So once you open this solution, what you'll find is that there's two projects in here. One is called todo.common and the other is called todo.windows phone 8. And as time goes on, if you clone this repo later on, you'll likely see todo.android and todo.iOS added in here, as well as we add the additional platforms as time goes on. The first part we're going to look at is the common library. And the thing to note about this common library is that it is built using a portable class library. We did that simply by coming into our solution and saying add new project, and from the new project we went and made a portable class library. Not just a normal class library, we wanted something that's portable, so that allows us to target Windows Phone, Windows 8 potential if we wanted to, and then in the future we'll be able to target Android and iOS through the Xamarin Tools by having a portable class library. So in the properties for the project, if you right click on properties for the common project, you'll see the target frameworks is an option, and this is specific to portable class libraries. This is where you can choose what your target frameworks are. As we move on in this series and add Android and iOS, we'll have additional options here to target those platforms as well. So that's the first thing to note. This common project is a piece of code that will be shared across all the platforms. We'll look at the UI here in a minute for Windows Phone, and that will be UI that's specific to an individual platform. So the first thing we're going to need to do is build some core functionality of our app that will be shared across all. What I'd like to do first is run the application and show you a quick overview of what it is. It's very simple, and then we'll dive in and look at the individual pieces of code that make this up and which pieces are shared and which pieces are specific to Windows Phone. So what I've done is just run the emulator from inside Visual Studio, pressing F5 or clicking on the play button. If you saw my earlier video, you'll be familiar with this and what the emulator is. This is booting up the Windows Phone OS. We'll wait just a minute and it should be ready. Okay, the OS has come up here and now it's deploying our application to the phone. And you can see that from inside Visual Studio down here in the footer, it's telling us what it's doing. And now the OS is launching here. See our loading screen, and now we've landed on our page. So we've got a simple page here that says to-dos. We've got a text box that has some data entry and an ability to add. A couple of quick notes about the emulator, some additional tips. If you need to do text entry and you're on your keyboard, your physical keyboard, it's kind of annoying to have to point and click here. So if you press page down on your keyboard, that actually hides the on-screen keyboard and it allows you to type on your regular physical keyboard like I'm doing now, instead of having to click on the on-screen keyboard. To bring that on-screen keyboard back up, you would just press page up, and that would enable the on-screen keyboard. Now when I click here, I've got an on-screen keyboard. I like to press page down and keep that on-screen keyboard off because it's just faster to type. So what our to-do app allows us to do is type in a to-do, click the add button, and it adds it to our list. And we can type in another to-do here, click the add button, and maybe one more, and click the add button. And now we're building a list of to-dos, things that we need to do, just keeping track of items. And we put those in the oldest one is at the top and the newest one's at the bottom. And then there's simply two options here. One is to check a box to say that that to-do is completed, and we turn the text green when we do that, or we can uncheck and turn it back to white. And then the other option is to delete a to-do if we're no longer interested in it, and we click the delete button and that disappears from our list. So that's basically the application we're going to be building. Very simple and straightforward. We're using a fairly simple UI here just to demonstrate some of the cross-platform aspects of mobile development. So let me jump back into Visual Studio here. I'll stop our debugging session and let me go through the basics of how we've structured this application. In the common project, which is our portable class library, we created two key classes. The first is what we're calling a to-do list view model. If you're familiar with the MVVM pattern, which is model, view, view model, some of this might be a review for you. If you're not, this should be a good introduction to MVVM, and these concepts are applicable even if you're not doing cross-platform, even if you're doing something like WP8, Silverlight. This MVVM pattern we're following here is very similar for all of those different products. The key to MVVM is the ability to have properties on your object that can notify the UI when they change. And we do that by inheriting from a class that we've called bindable. And this is a class we implement. This is part of the GitHub repo. This is one of the key tenets of MVVM, is to implement the iNotify property changed interface. And that interface allows us to notify the UI when the value of a C# property has changed. And that allows the UI to update. So if we run our application again, I'll show you some of the examples of this. So one example might be when I add a to-do and I check this box, I'm changing a property on a view model that says that this to-do is completed. When that value changes to is completed, then I want to go change this text to green. So I need some way, some notification pipeline to get in and out of the UI and tell it when to update. And we do that through iNotify property change. So the next thing you see here is an observable collection of type to-do item, and it's a public property that's available on our view model, and in the setter we're calling on property changed. And that is how we notify the UI that the value of this property has changed, and so the UI should reload whatever is data bound to it. We'll get into this in a minute. Let's look at what a to-do item is. So a to-do item here is a bindable as well, and we already looked at what bindable means, just implements iNotify property change. And this item has two properties. It has the text and it has an is completed flag. And so that is the individual items that we're adding to the list. Whatever we type in that text box and we click add, it gets set as the text, and when we check the checkbox next to it, we set the is completed flag. This right here, to-do item, would be what we would consider our model object in this project. It has two properties on it. They're just a plain old CLR object. You might hear them called POCOs, plain old CLR objects. And these are just simple types, a string and a Boolean, with getters and setters on them. In our MVVM pattern, our VM, our view model, is what we started looking at here, the to-do list view model. It contains a collection of our model objects. And we wrap that in an observable collection, which is specific to the view layer, to be able to notify of changes inside the collection when items get added or removed from the collection, like they would when we delete a to-do item. That would notify the UI for us. So far we've been in the common project, and that's shown us our model, which is to-do item, and our view model, which is to-do list view model. The next piece, or the last piece of the MVVM pattern, would be the view. And the view, in the case of Windows Phone, is always going to be some sort of XAML file. It's going to be the actual markup that shows the UI. So in our to-do.windowsphone8 project, we have a mainpage.xaml. and main-page.xaml is the view we were looking at when we ran our application. We start simply with a grid and some rows. The layout of the XAML isn't so important. The things that we want to look for is how we're data binding the view model properties to our UI. Okay, so the first thing we're looking for in our view to figure out how it's data bound to our view model is this binding keyword. And we see this show up in two places in our view right now. The first is binding, and this path is equal to add command, and we can see that that's on a button called add. So we know that's our add button. And when we click on it, we're going to execute the add command. So we're binding the command property of a button to the add command property on our view model. The next place we see binding is on an items control, and we're binding to a path is equal to to-do items. So there's a public property on our view model called to-do items, and that is a collection of to-do item model objects, and we're binding that to an items control. And we know that this binding is pointing to our view model because we're looking for where the data context is set. If we look all the way at the top of the page here, you can see that right in XAML, we're setting the data context property equal to an instance of our to-do list view model. So when we see this and we say that the data context for the whole page, the entire phone application page's data context is set to an instance of to-do list view model, we know that everything within the page, which is all of this XAML in here that I just collapsed, everything in there is looking at the to-do list view model when we do a binding. So if we see, for instance, here we see binding path equals to-do items, we know that we need to go look at the to-do list view model and find its to-do items public property. So we'll go back to to-do list view model again, and we can see that we've got a public property called to-do items, and that was our collection of to-do item, which was our model class. So this is a collection of our models. So this getter, which is going to return this private property here, that getter is what's being shown in our view through data binding. Okay, so what we know is that when the view model is newed up for the first time, this list is set to an empty collection. So we're setting the private property underscore to-do items equal to a new observable collection of to-do item paren, and we're not adding anything to it. That means that when the app runs the first time, I'm going to go ahead and run it one more time, the list that we're showing in the items control is empty. And you can see that because underneath our text box, there's no items showing in our list. And that's because we data bound to an empty collection to start. The next piece we're going to look at is the data binding for the command when we click the add button. So on our button, we have an add command that's being bound to the command property of a button. This just means that when you click add, we want to fire a method that's in our view model. And the other piece to note, we have binding here as well. On the text box, the piece that you type into, we're binding to new to-do item dot text. Now this is a little bit interesting. There's a dot in here, so this syntax might be a little confusing, but remember that anything that's in a binding is within our current data context. Our current data context, again, is our view model object. And so we're looking for a public property in our view model called new to-do item. So we'll go back and we'll take a look, and here it is. Here is new to-do item. Here's the public property, new to-do item, and its getter is returning this private instance, new to-do item, which we set to an empty to-do item. So remember, to-do item is our model in this pattern. It's the M in the MVVM, and we're setting a public property on our view model of that type, and it's going to be blank to start. It's just going to be a new instance. And then on the setter, we want to call the property change. So when we type into this text box, we're telling the text box to data bind the text property to that new item's text property. So as soon as you start typing, we want to push the data from the UI down into the property on the view model. And that would be what's called a two-way binding. And in text box, the default is a two-way binding. So you may not see this mode always specified, but it's specified here just for clarity. So this two-way binding means type into the text box, push the data down to the view model, and sets the new to-do item .text property to whatever I typed in. Okay, and now let's take a look at this add command in the view model. When we click that button, what happens? Well, we can see here's the add command, public property, and it's of type delegate command. We'll take a look at that in just a second. And the thing that we need to know basically is that a delegate command has two handlers, one that handles the execution and one handles what's called a can execute. In the case of can execute, for our example, we're always going to return true. Can execute gives you a place to decide whether the button's enabled or disabled. You can perform some Boolean logic and decide whether you want to allow the person to actually click the button or not. For our cases, we're always going to allow the button to be executable. So the return value of can execute is just always true for us. The more interesting method is the actual execution. So when the button is clicked, here's the code that will run. And notice what we're doing. We're taking our to-do items collection, remember, which was a public property on this view model, and we're adding to it the new to-do item. So I'm going to put a breakpoint here, and we're going to walk through this. So I'm just going to Alt-Tab over to our running application. I'm going to type into my to-do box and say to-do item 1, and I'll press add. Now when I press add, notice that my breakpoint came into the execution handler, the add executed handler for my add command. And if I look at new to-do item, you can see that the text property is set to do item 1. And that's what I typed into that text box. And that was done, remember, because we've got a two-way binding set up on the text box that says, on my view model, set its text property to whatever I typed in the box. So on my view model, set the new to-do items dot text, which is off the to-do item, set that equal to what I typed in, which is to-do item 1. Now I'm going to take that model object and add it to our observable collection of to-do items. Right now there's nothing in the collection. I'm going to press F10 to step over. And now I've added one to-do item to our collection, and that to-do item, its isCompleted property is false, and its text is set to to-do item 1. The last step I'm going to do is just set the new to-do item equal to another empty to-do item. And I'm going to go ahead and press F5. Now we'll notice that what I just typed in shows up in our list below, and the text box above is now blank again. So that allows us to have an empty item for entering to-dos each time. Each time we click add, we take the item that's been populated and add it to a list. And this list refreshed, remember, because we're data bound on the view, we're data bound to the to-do items collection. And in our view model, remember, that collection is an observable collection. That means that by default, the framework is going to notify our UI whenever any of the items in the collection changes. And we're changing the items in the collection right here by calling .add. When we add a new item to our collection, it'll fire a notify property change. It's actually a notify collection change event to the UI to say, hey, there's a new item in the UI. You need to refresh your data binding. And it looks like I tabbed out of our app. Let's see if we can get back here. So let's type something in, add, and so that refreshes the data binding, and it will update the UI to show the new item in the list. Okay, we've only got two more commands to look at. They'll be very quick, and then that'll be it for our overview. The first one to look at is how we're doing the completed. When we check the box here, you'll notice that the text is turning green, and some of that's happening through some UI bindings. So let's first take a look at the checkbox. We want to know, when I check the box, what code is firing. So we know that those checkboxes show up, and let me Alt-Tab back here. These checkboxes show up for all of our items. So if I just keep typing a bunch of items in here, you can see I get a checkbox for each one, and I can check them independently. So we know that that checkbox is tied to each individual item. So the place we want to look is in our items control. Let's look at the item template. So we want to look at our items control, which is showing all the to-do items, and we want to look at what is the UI for each of the items. That would be the data template that's tied to the item template. So here is the snippet of XAML that's used for all of the items. We can see there's a stack panel, and we've got a checkbox a text block and a button, and they're stacked horizontally. So if we go back and look at our UI, stacked horizontally, checkbox, text box, or text block, and another button. So it looks like we're in the right place. Now we start looking for bindings. So is checked is bound to is completed, and it's a two-way. So remember that our data context is our view model, so now we're looking for a public property called is completed on our view model. So we'll flip back to our view model, and we'll look here for is completed, and we don't see it. So this is where some people might get tripped up. The thing to note in our view is our items control, the entire control, its data context was the view model. It was the full collection of to-do items. But once we're inside an individual item on the items control, the data context has changed. Because think of it like a for each loop. So for each to-do item in to-do items, do this. So when you're inside that loop, the context that you're dealing with is the individual item, not the whole collection. So now all this UI, when we say binding, this is bound now to an individual item that's in this list. So let's go back to our view model. We'll look at our list of items. Here's our overall list, and our individual items are to-do items. So I'm going to press F12 to just go to definition, and now we're inside of an individual to-do item. Now we see an is completed Boolean. Okay, now when we go back to the view, this starts to make sense. The is checked on the checkbox is set to is completed. So as you check and uncheck that checkbox, it turns the Boolean flag on our model to true or false, depending on what you're doing. Now, that makes sense. So again, our to-do item, we've just got a Boolean. We're just setting it to true or false based on when you're checking. So we're binding the UI to a Boolean property inside our to-do item. The next piece is the text block. The binding for the actual text is the text property on the to-do item. So again, binding path equals text. And so we look back at our to-do item. Here's the text property. That's how we're showing the text. Now, how do we make it green or white, depending on whether it's completed? Well, here's a little trick. So we say the foreground, which is a color, is bound to is completed. Now, is completed is a Boolean property. So obviously true and false is not going to change the color. So we have to convert that value somehow. So you can do that using a converter. So on the binding, we can say the binding is pointed to is completed, which is a true or false value, but we want to convert that true or false value to, and we created a converter called completed to foreground color. And if we look up in the resources for this page, you'll see here is a reference to our completed to foreground color converter. We can just press F12 there and go to definition. And if I look in the Solution Explorer, if I say View Solution Explorer, you can see right here under our Windows Phone project, we have the completed to foreground color class. This is simply implementing the iValue converter interface that has two methods, convert and convert back. You're almost never implementing convert back. All we care about here is to convert. We know that we're getting a Boolean in, a true or a false. We need to parse that Boolean and then make it the color that we want. So what we do is we make sure that we actually got a value, it's not null. Then we try to parse the value to make sure it's a valid true or false option. And if that succeeded, if the parse worked there, then we'll do a simple little Boolean here. If it is completed, return the color green. If is completed is true, return green. If is completed is false, return white. If something else is wrong, like it wasn't a valid Boolean or the value was null, just use the color white. So if I go and put a breakpoint here and I go back to my app and I check a box, as soon as I check that, you'll see that it comes in here and it passed true because I just hit the checkbox, which means the is completed value is true. And so now we're going to step into this code and we're going to say, well, is completed is true. We're going to return a solid color green, press F5, and that's how it's green. Let me take this breakpoint off and show you again. Uncheck it, it goes to white. Check it, it goes to green. So we're just converting our Boolean to a color. This is a view-specific logic we're doing here, and it's done through data binding. So back to our view again. We're data binding the is completed flag of the current to-do item. Remember, for each to-do items for each to-do item in to-do items. That's how you can think of this template. So we're on an individual item, we're binding its isCompleted flag, and we're converting a Boolean to a color. And we wrote that conversion logic in what's called an I-value converter. Okay, and the last piece to look at is the delete. And at this point, it should be pretty straightforward. Delete's a button, it's got a command. Now, one tricky bit here is, remember, inside this data template, if we were to say path equals delete command, if that's all we said, it would be looking for a delete command property on the to-do item. And that's not where we want the delete. Each item doesn't need to know about its delete. We want the overall view model to handle deleting. So we need to somehow go find the data context that is the view model and bind to that instead. So in Windows Phone, you're a little limited in how you can navigate the data bindings. But one thing you can do is bind to another element on the page's data context. So we're just going to bind to the content panel. We just say element name equals content panel, which is the root grid here. Its name is content panel. So within this binding, we say go up the tree, find this element, which is a grid, and use its data context, and then find its delete command. And remember, the grid's data context is our view model. Right? Remember, anything outside of this item template, to-do items, or the add command, or new to-do item, those are all part of the view model. So we know that this guy has the right data context. Inside of our item template, our data context for this is an individual to-do item. We need this button to link to the delete command that lives on the parent data context. So we simply say element name equals content panel, path equals data context dot delete command, and we send a command parameter of binding, which means send the current item. So just binding with nothing else just sends the full to-do item. So now we need to go look at our view model and look for a delete command. And I'll come in here and collapse a few things for us. And you can see we already looked at add command. We have a very similar pattern that is delete command. And again, can executed is just returning true for us here just by default. And now look at our delete handler, very simple. It goes to our collection, calls .remove, and removes the item that was passed in. And the item passed in, remember, is this command parameter. The command parameter on the end here is passing binding, which is going to be the current to-do item that it's on, that you click the button for. It'll be that entire item. So when we go back to our view model, we just say remove that item from our observable collection. And remember, when we modify the collection, the observable collection object notifies the UI for us. So I'll switch here and I'll go over to our third item down, and I'll go ahead and put a breakpoint, and I'll click the delete button. And now what we're passing in is the to-do item we want to delete. We can see the text is what we had there on the third item. And we look at to-do items itself. It has 4 items total. And we're just going to say, go ahead and remove this one that I gave you. And when I do that, now you can see we only have 3 items. And I'll go ahead and delete the first one. And that first one was marked as is completed true. So let's take a look here and we can see is completed is true. And here's the text for that first item. So we know we got the right one. And we're just going to go ahead and remove it. And I'll go ahead and press F5, and you can see it got removed. Okay, that's the basics of the to-do application. That is the basics of MVVM inside of a Windows Phone application. One last thing to look at, and you'll want to study this in the code on GitHub a little further, is this delegate command class. This is unfortunately the Microsoft implementation of MVVM, which they didn't really implement it. It was a suggested pattern, but Microsoft doesn't provide this class out of the box. So this class has been provided as part of this code base. You'll see this in many MVVM frameworks. If you look at something like Caliburn Micro or MVVM Lite or any class that does MVVM, you'll see something like this. It may be called a relay command. It may be called a delegate command. It may be called something else. But the basic idea is that you're able to pass functions. For those of you that maybe aren't as advanced in C#, this might be an advanced concept for you. So study up on what an action or a func is. There are basically 2 specific delegate types. A delegate in C# is simply a variable that can hold a function. So it's a function as a first class language. If you do any JavaScript programming, you'll be familiar with this concept of passing functions around. So what we're doing in this delegate command class is allowing you to pass two function pointers. Think of them as function pointers if you're from C++ land. You're able to pass two functions into this object, and it will hold a reference to those functions. And then when you use the command, it will execute them. And in order for us to use the command in the UI and XAML, we need to implement the iCommand interface. So in XAML, when you're binding to a command property, it expects the object that you're binding to implement the iCommand interface. If it does, then the UI knows how to invoke the command. So as long as we provide a class that implements iCommand, then we can do whatever we want inside that class. And so when I flip back over to delegate command here, you can see I'm implementing the iCommand interface. This chunk of code is the code that we wrote. This is the idea of passing functions around. This nested chunk of code here is the iCommand implementation. So this is just wiring up our class to use the iCommand interface. And basically you implement can execute and execute. And execute's pretty straightforward. We're just calling the execute action, which is the function that got passed in. So let me just debug. It's probably easiest to see this through the debugger. We'll go ahead and run this again. And I'll put a breakpoint here. So here we're calling delegate command, and if I go up the stack one, you can see that it's the constructor of the view model that's constructing the add command, and we're saying if the add command is null, which it is, create a new delegate command object and pass it these two functions, add executed handler and can execute handler. And look, here's the add executed handler. That's just a method. So we can pass a method by name as a parameter by using delegates. In this case, an action, because it doesn't return anything. In the case of can execute handler, we're passing what's called a func because it returns a value. So we pass these two method names. Again, think of them like function pointers or functions as a first class object. And now we're storing a reference to that function inside this object. So now this dot execute action is a pointer to that function. So now I press F5 and we type in something and we click add, and now add is invoking the iCommand execute method. So we've implemented the iCommand interface, so the UI now casts our object as iCommand and calls execute on it. And if we had passed a parameter, it would pass it. And so what we do now is now the UI has executed, and now we're just going to turn around and call the method that you passed in. So now when I press F11, now you can see now I end up in the add executed handler. And so now I'm running my code that lives in the view model. This is really key to understanding MVVM, this ability to separate the command handlers from the UI. So we can do this, we can stick command handlers inside our view model by using something like a delegate command. Like I said, it may be called relay command. There's several other names out there. I like to call it delegate command. So now our code runs, and then we go ahead and run through and we get the to-do added to our list. If we didn't have the ability to do delegate command, you would see something like this. Instead of being able to say, let me go find our add button. On our add button, instead of being able to say command, what you would have to do, I'm going to stop running here so I can edit code. Somebody might think to do click, and now you say, go ahead and add a new event handler, just button click. Right? But look where button click gets added. It gets added to the code behind of our application. And you can't put that handler anywhere else. It has to live in your code behind. That's because this is a partial class, and the other part of the partial is the XAML. And event handlers defined in a partial class have to live in one of the two partials. So this handler has to live in the code behind. There's no other options. You can't put that anywhere else. So what's the problem with that? Well, when we get into the later series of this video, we're going to be porting this code to run on Android and to run on iOS. And the adding of a to-do item to our list is a common piece of functionality that we want to work the same way across all three platforms. So now you can see if we had to do click handlers and they have to live in the code behind, Now we have to re-implement this code every single time when we go to a new platform, and we lose code reuse. So I'm going to go ahead and delete this, and I'm going to delete this, and we're now able to say the command is data bound to the add command property that lives on our data context. And let me jump out of here real fast. Go back to our view model. It's bound to this public property, which is itself a delegate command, which remember is a wrapper around functions, and it can dispatch the call to the function here. So that's how the delegate command plumbing works. We'll dive into this a little bit further in future videos, and when we get into building this application for other mobile platforms, it should make more sense. Again, if you're not part of the San Diego Tech Immersion Group and you're in the San Diego area, I highly recommend that you join us. We're starting our new track January 22nd, 2014, and you can get all the information for the group if you go onto the web and you look up sdtig.com. You can get all the information that you need right here on the homepage. It explains where we meet and when we meet. So if you're in the area and you'd like to join us, it's free to come. We'd love to have you. And we meet once a month, and we're starting this new cycle on January 22nd, 2014. If you're not in the San Diego area, but you still want to follow along with this video series, you can get the code from a GitHub repository. If you go to GitHub and you search for TIG cross-platform mobile, then you should be able to find our repository, and you can clone that repository down, and that's the code base that I just demoed in this video. So you should be able to follow along. Okay, thanks for watching, and stay tuned for future videos on cross-platform mobile.